Hello everyone, my name is Dylan Vo. Welcome to my presentation of the 2013 through 2014 Stanley Salmonella outbreak. I'll be taking you through a 7-step analysis of the public health officials' response towards containing this outbreak. First off, let's gather some background info. What is Salmonella? Salmonella is a type of bacterial pathogen. There are numerous types of Salmonella, classified into serotypes by the type of structures present on the surfaces of these bacteria. The bacteria responsible for this specific outbreak is Salmonella enterica serovar Stanley, or S. Stanley for short. There are numerous modes of transmission across different strands of Salmonella, but for this outbreak, the main culprit is raw cashews, sourced from Southeast Asia. These cashews were then made into raw cheese by the company called The Cultured Kitchen and sold. The symptoms of the Salmonella poisoning included diarrhea, vomiting, stomach issues, cramping, and nausea, all varying in severity from mild to severe. Generally, Salmonella does not involve any special medical care, but some may be hospitalized or risk death. Salmonella poisoning can affect anyone, but is especially dangerous in unsanitary food conditions or in immunocompromised people, such as young children, the elderly, and people with immunocompromised conditions. They will have trouble fighting off this bacteria. This outbreak had a prevalence of 17 individuals infected. 15 of these individuals were from California, 1 was from Nevada, and 1 was from Wyoming. While there were no deaths in this outbreak, 3 individuals had to be hospitalized. Next, let's analyze the current situation. What are some factors we have to consider for our response? We need to consider the long shelf life of our product, the raw cashew cheese. These cheeses are designed with preservatives to last as long as possible in people's homes. We also need to figure out how to reach out to those at risk before they get sick. How would we reach the greatest audience? Radio, television, newspaper, etc. Next off, since Salmonella is such a common occurrence, how will we know that a certain Salmonella case is in fact caused by our cheese? While secondary to safety concerns, we also need to consider the financial stability of the cultured kitchen. Its operation will have to shut down until we deem conditions free of Salmonella, and it may face legal backlash from consumers and the law. Finally, we should consider international trade diplomacy. If we blame the external vendors from Asia, we risk severing this trade market. One strength our response has is the PulseNet database. This database contains info about DNA fingerprints on Salmonella strains. This makes it easy for officials to identify what Salmonella cases are tied to our cheese outbreak. A weakness we face is cross-state communication. As this course teaches us, coordinating across departments, especially in different states, heavily slows down response time. An opportunity of this outbreak is to document Salmonella Stanley. In America, the strain is rarer, with only 20 documented cases in the database. A threat is the long shelf life of the cheese products. Consumers could have not seen the recall and kept the cheese in their pantries, causing more sickness in the future. What issues do we need to prioritize in our response? Salmonella Stanley can live on food for weeks even in refrigeration. It can use animals as reservoirs for transmission, and most importantly, it is found in our raw cashew cheese. There are multiple factors that contributed to the failure of ensuring our cheese was Salmonella free. First, there is no kill step. No procedure exists to kill the bacteria present in the cheese. There is also no quality control like a microbial analysis at the end of production to ensure no Salmonella survives. Finally, the cashew vendor is unchecked for quality and was not documented for future reference. Here are 2 alternatives we could utilize. First, we could sterilize the product using a pasteurization. While consumers are scared this may affect the quality or nutritional value of the product, pasteurization does not affect this. We could also implement higher quality control, either in the finished product to ensure no surviving Salmonella, or in the crude product bought from vendors. In terms of the socio-ecological model, these changes would increase individual trust in the company. These individuals are then more likely to recommend the product to their community. Additionally, the cultural kitchen would be safer from future legal and financial trouble that comes from damage control of another outbreak. The cultured kitchen could also team up with other raw food vendors to afford quality control services. Finally, the FDA, USDA, or other government agency could implement policy for mandatory quality testing or pasteurization. Using this model, we can see connections between all levels of our society and how our actions as public health officials affect these levels. My final recommendations are to implement either a kill step or quality assurance step in the manufacturing process. For kill steps, we can use thermal pasteurization or pressure pasteurization called high pressure processing. For quality control, we can either vet quality at the very start of the process with vendors or at the very end with the finished product. Let's establish an action plan for implementing a kill step. Our goal is to eliminate Salmonella bacteria in our products before sending them out to consumers. The method we will be using is thermal pasteurization. The cultured kitchen manufacturer is responsible for implementing this procedure. Our timeline should take approximately half a year to a year. First, we need to fund research into ideal pasteurization conditions for our cheese. With high fat content products, typically either vat pasteurization or high temp short time pasteurization is used. Vat pasteurization takes longer but is undergone at a lower temperature compared to high temp short time. This would take a couple weeks to months depending on how much funds are available to the cultured kitchen. Next, we install the pasteurization equipment in our factory, which will take a couple more weeks to months. Then we need to train our workers to operate our new pasteurization machinery, taking 4 to 8 weeks. Finally, we can run a 2-month pilot, gathering information from labs and customers to ensure quality and safety remain unchanged. If any conditions are off, we must undergo the process all over again. Let's end our assessment by comparing it to a similar outbreak case. In England and Wales in October 1989, unpasteurized Irish milk turned into raw brie cheese resulted in an outbreak of Salmonella Dublin. 42 individuals were infected, mostly adults living in southeast England, but no deaths were reported. Their solution began with interviewing those infected with Salmonella Dublin. After identifying the likely origin, they recalled the cheese sold in stores. Then they provided food hazard warnings to health departments, and the health department issued a press release. The manufacturer decided to pasteurize the raw cheese from then on, and the sales resumed within the year in July 1990, taking about 8 months to resume operations. In my opinion, I think the officials in this case performed about equally with those in our case. Both solution timelines of these cases were very effective and efficient, resolving in months. However, I believe that the UK did better to assuage the public's fears. Instead of just reporting on the matter in paper files, the health departments issued a physical announcement designed to answer questions and assure people that they would be all right. In the event of public health disaster, damage control and maintaining the people's trust and confidence are of utmost importance. The less trust public health officials have, the more the people will rebel against them, potentially leading to even worse disasters in the future. And here's my reference page. Thank you so much for tuning in to my presentation.